All right, we're going to look at how do we solve absolute value inequalities. So you can solve absolute value inequalities by rewriting them as compound inequalities and then solving each part. But they come in two forms. So first is if we have less than. So if we have the absolute value of ax plus b is less than c, to rewrite this as a compound inequality, we're going to need to bring a negative c into the front here. So negative c is less than ax plus b, which is less than c. Okay, so to get rid of the absolute value, we had to bring this negative c in front. This, of course, is an AND situation, so its graph is going to look something like this. Whenever you have a greater than, so for this case I'll say ax plus b is greater than c, then we have to say, okay, this is either ax plus b is greater than c, or, so notice that we've pretty much kept it the same. We just stripped away the absolute value signs. But because it's absolute value, it could be ax plus b is less than negative c. Okay? So whenever we have a greater than, we end up with an or situation where our absolute value is going to face in two different directions, and whenever we change it, we also change our c. Since this is an or situation, our graph would look something like this. All right, so we're going to do some examples of each. Right here in this example, we have the absolute value of x plus 2 is less than 6. Because this is a less than symbol, to solve this, I'm going to have to bring a negative 6 in the front and say, okay, negative 6 is less than x plus 2, and x plus 2 is less than positive 6. So x plus 2 is between negative 6 and 6. Then I just go about solving. I subtract 2 from each side. Negative 8 is less than x, less than 4. Okay, whenever we plot this on our number line, it would be between negative 8 and 4. Neither are included, so they each get an open circle. And all of the x values are trapped in between negative 8 and 4. So all of my shading is going to be right here. If I were to write this in interval notation, that would be from negative 8, not included, to 4. All right, let's do one more example. Here we have the absolute value of 2x plus 1 is less than or equal to 9. Since it's again, we have the less than or equal to. So negative 9 is less than or equal to 2x plus 1, and that is less than or equal to positive 9. I'm going to subtract 1 from all of the sides. Negative 10 is less than or equal to 2x, and 2x is less than or equal to 8. Now I divide everything by 2 to isolate the variable, and negative 5 is less than or equal to x, less than or equal to 4. Whenever I plot this on my number line, I have negative 5 and 4. Now they're both included, so they both get solid dots, and all the shading would be right here in between. So in interval notation, since they're included, we use brackets, negative 5 to 4. All right, now let's look at the example. The absolute value of 4x plus 5 is greater than or equal to 13. So since it's greater than or equal to, remember that we split it up into a compound inequality like this. We take the original without the absolute value. 4x plus 5 is greater than or equal to 13, or what's inside the absolute value, 4x plus 5, is less than or equal to negative 13. Now we just solve each of these. You subtract 5. 4x is greater than or equal to 8. Divide each side by 4. We have x is greater than or equal to 2. Or, subtract 5 over here, 4x is less than or equal to negative 18. Divide each side by 4. And x is less than or equal to negative 18 over 4. They're both divisible by 2, so that's negative 9 over 2. Negative 9 over 2 is negative 4.5, so on my number line here, that'd be between negative 5 and negative 4. Over here I'm going to put my 2. Okay, so the negative 4.5 is included, and all of the x's less than that are going to be out here to the left. And x is greater than or equal to 2, so the 2 is included, and all the x's greater than are to the right. And we knew it was going to look like this because it's an OR situation anyways, and the OR is always split off in different directions. And in interval notation, this would be negative infinity to negative 9 over 2. And we have to jump, so union 2 to infinity. All right, let's do one more example and call it a day. I'm going to do the absolute value of 2x minus 7 is greater than 1. Okay, so we get to keep the original whatever was inside. 2x minus 7 is greater than 1. Or 2x minus 7 is less than negative 1. So remember, both of these things change. All right. Go about this. We can do both at the same time. We know that we need to add 7 to both sides here. So 2x is greater than 8, or 2x is less than 6. These all need to be divided by 2. So I have x is greater than 4, or x is less than 3. And I realize that these are written kind of backwards from where they'd be on the number line, but I always like to keep my original first. So on the number line, here we have 3 and 4. Neither of these are included, so x is less than 3 would be all of these x is less than 3, or x is greater than 4. And interval notation, that'd be negative infinity to 3, union from 4 to infinity. And that's how we solve absolute value inequalities.